So we're going to be learning how to factor and solve polynomial expressions. This is an extension of what we were learning in chapter 4 when we were going over factoring. So one of the methods is to look for a greatest common factor. I always do look for a greatest common factor no matter what, but especially when you see a lot of different variables and exponents, this is a good method to use. So here in number 1, I'm going to start by looking for a common factor. So for example, if you focus on the coefficients 14 and 42, the biggest number that both 14 and 42 can both be divided by is 14. So I'm going to factor a 14 out. And then if you look at your variables, both of these have an x. You always want to use, from these terms, the one with the lowest exponent. Because for example, x to the first power can go into x squared, but x squared can't go into x to the first power. So we're going to use x to the first power. So there's an imaginary 1 here. And then y squared can go into y cubed, but y cubed can't go into y squared. So you take the smaller one. So I'm going to take a y squared out. And then that's already factored out. Now we see what will go on the inside. If you need to, you can divide to figure this out. So you don't have to write this next step, but it does help to visualize the problem. So here, for 14xy squared, the 14s would cancel. X squared divided by x is x, and the y squareds cancel. So you would only factor out the x from there. If you were to multiply these, you would get 14x squared, y squared. Here, 42 divided by 14 is positive 3. The x's would cancel, and y cubed divided by y squared is y. So in our factor, we would have x plus 3y. If you were to multiply these together, you would get the term we started with. Question 2, I see a lot of variables, a lot of exponents, so I'm going to look for a common factor. First, we look at the 35, 60, and 15. The biggest number that all of those can be divided by is 5. So I'm going to factor out a 5. Next, I'm going to look at the x's. I have x cubed, x to the 4th, x to the 10th. I use the smaller one, which is x cubed. If one of them was missing an x, then we wouldn't be able to factor out an x. Now for the y's, I have y to the 4th, y, and y to the 7th. Y is the smallest, so that's the only thing I can factor out. So now I'm going to go one by one and see what would go on the inside. So for the first term, 35 divided by 5 is 7. The x cubes cancel, and y to the 4th over y is y cubed. Because remember, when you divide, you subtract exponents. 60 divided by 5 is negative 12. X to the 4th divided by x cubed is x, and here the y's would cancel. 15 divided by 5 is positive 3. X to the 10th divided by x to the 3rd is x to the 7th. And y to the 7th over y to the 1 is y to the 6. So those would be my factors now. And usually if there's more than 2 terms in the inside, you want to see if you can factor anything out of there. But 7, 12, and 3 can't be factored. So these would be our 2 factors. Now, in chapter 4, we had talked about solving using factoring. So here we have an equation equal to 0. Remember, you want to set them equal to 0. From there, we're going to factor. So both of these, 10 and 6, can be divided by 2. And a squared and a, you can take out an a. So if I work backwards, here I would get 5a minus 3. So those are my factors, and now I can set each one equal to 0 and solve. So here, if you divide by 2, a equals 0. Here we get 5a equals 3, and then you could divide by 5. So a equals 3/5. So our solutions are a equals 0 and 3/5.